Okay, in this video I will be working on a free response that has to do with fluids. And the free response says, a cylindrical tank containing water of density 1,000 kilograms per meter cubed is filled to a height of 0.7 meters and placed on a stand as shown in the cross-section above. A hole of radius 0.001 meters in the bottom of the tank is opened. Water then flows through the hole and through an opening in the stand and is collected in a tray 0.3 meters below the hole. At the same time, water is added to the tank at an appropriate rate so that the water level in the tank remains constant. And the first part of the question asks us to calculate the speed at which the water flows out from the hole. And this question has to do with Bernoulli's theorem. And it means that we have to look at, choose 2 points in the problem. In this case, we should look at point 1 being the top of the fluid in the tank, and then point 2 being the hole. And that's where we will find the speed of the water escaping from the hole. So, writing out the equation. So part A, we have pressure so this is all dealing with point 1, which is up here. And that we set it equal to and this is point 2, which is at the hole. And we're trying to find the velocity. So there are some things we can cancel out. The pressure we can cancel out because it is atmospheric pressure, so they're the same thing. And we can also cancel out the velocity at point 1, which also cancels all this out, because it is not moving. We can also cancel out, get to that. Okay, so now let's simplify. Get P squared 2. Then we subtract this from that side, which gives us PG times y1 minus y2, simplified version, equaling half PV2 squared. Now we can cancel out the densities, because they are both 1,000 kilograms per meter cubed, and multiply 2 on both sides, 1 minus y2, and I'm also going to square it, square root it, to get v squared. Now there's also one more thing that we need to cancel out, because looking at this, we have to figure out what exactly our y1 and y2 are. Y1 is definitely 0.7, because we're going from the bottom to the top, and that's 0.7, 0.2 from 0.1. But we're not at all looking at what's happening with the stand. We're just looking right now at the tank. So that means that 0.2 at the hole is actually 0. The height is 0 there, because we're just looking here. So that means that we can cancel out y2, and our working equation is simply the square root of 2gy1. And when we plug in our numbers for that, we get 3.7 meters per second, equaling our velocity of the water flowing out of the hole. And then for part B, it says calculate the volume at which water flows out from the hole. And to do that, we have to take the velocity that we just found and apply it to the area of the hole, which means that we would just take the velocity and times it by the area of that hole. But it doesn't give us the area, but it does give us the radius. So since area is pi r squared, it simply means that our volume rate of the water, which I'm calling VR, is equal to the velocity at the whole times area, which is v squared times pi r squared, like that. Move it up. And that gives us, when we plug in 0.001 meters for our radius and the v squared from part A, or the v2 from part A, we get 1.162 times 10 to the negative fifth meters cubed per second for our volume rate of the water. Okay, so part C asks us to calculate the volume of water collected in the tray in time 2 minutes. So for this question, you can look at units to help you figure out what to do, and since these questions always build off each other, since our volume rate was volume over time, we can, to find the volume then, we would just take the volume rate times time, and that would cancel out time and give us just volume, or meters cubed. So, other words, that would be volume equaling volume rate times time. And in this problem, it asks to find the volume of the water in 2 minutes, but we're using seconds, so we can't forget to convert. So that would be 2 minutes times 1 minute over. So that is the conversion, and so for our volume in the tray, at 2 minutes we get 0.0014 meters cubed. Okay, thanks for watching.